Okay, so this question says, consider the following chemical reaction. Assume that the density of carbon disulfide is 1.2 gram per mil. Okay, so we have to first write out the fully balanced equation. So I'm just going to write out this equation. And this balancing might take a bit of trial and error because it's a pretty long equation. And also, it's sort of a non-standard equation as well in many ways. Okay, so when we're balancing this, we might start off by putting a 3 in front of here. And that's because, well, a 3 in front of there, and then possibly a 2 in front of here. Let's check. So my justification in putting a 3 and a 2 there is because I can see that the carbons, for the carbons to be balanced, there's 3 of them now, and that balances with this. More importantly, for the sulfurs to be balanced, there are 2 sulfurs there and there are 3 sulfurs there. So you always think about the ratios 3 and 2, but you have to put them on opposing sides of the molecule of the equation. So now we have the sulfurs balanced, and we've got 4 plus 2, so 6 sodiums. So we put 6 there. And now we focus on balancing everything else. So we know that carbon is balanced. We know that sodium is balanced. We know that sulfur is balanced. All we have to focus on now is hydrogen and oxygen. So we have oxygen, we have 6 of them, and we have 6 hydrogens. Whereas on this side, hydrogen and oxygen, we actually only have 2 hydrogens there and 1 oxygen. No, we have more than 1 oxygen. We have 1 oxygen in the water and we have 3 oxygens there. So we have 4 oxygens so far. Okay. So quite possibly if you times this by we have to times it by 3, wouldn't we? Yeah, if we times that by 3, we get 6, and then the number of oxygens we have, there are 3 oxygens there, and then we go plus 3 times 1 oxygen each, so plus 3 equals to 6. So now our whole chemical equation is balanced. So that was quite a challenging balance there. And you may have taken a few attempts to try. You may need to balance it a few times initially. But the important thing is to leave the oxygens and hydrogens at the end and balance the more complex molecules. So, question 2. If the equation is only 80% efficient and the volume of CS2 reacted with excess bromide was 90 ml. So the volume of this is equal to 90 ml. Find the mass of sodium carbonate formed. Sodium carbonate. That's this. We need to find the mass of sodium carbonate. And so therefore, because this is not necessarily, it doesn't tell us about whether it's an enclosed vessel or anything. It just tells us that a reaction is occurring, gives us a density of CS2. We may need to use the volume of CS2, which is 90 mL. And we also need to use the density of CS2, which is 1.25 gram per mil. And then we can say, the way we can use the densities, we can say that, okay, 1 mil of this solution weighs 1.25 grams, and we know that we have 90 mil of the solution, and we don't know how much grams we have. Okay, so you can then just cross multiply. So X, which is the grams of carbon disulfide, you multiply it by the one there, and then you multiply this by that. So the proportion should always be maintained, because the density should still be the same. Okay, so 90 times 1.25, that gives us 112.5 grams. So that's the mass of, instead of expressing it as volume, we know the mass. Mass is equal to 112.5 grams. And from that mass, we can now calculate the sodium carbonate that we want to find. So the mole of CS2 is equal to the mass of it divided by the molar mass. So the molar mass of this would be 12 plus 2 times 32. And then we end up with, I think, 1.4048 mole. Okay, so and finally we find the mole of sodium carbonate, which we would have to multiply by a factor of. If we look at the reaction over here, okay, the ratio of that to that is you times it by 1 over 3, which is what you want over what you don't want. Okay, so 1 over 3 times by the mole that we got from our calculations means that the mole is going to be 0.493,421. Okay, so that's the mole of sodium carbonate, and then we can work out the mass of it as well. So the mass is the mole times by the molar mass. So the molar mass in this case is 23 plus 12 plus 48. So 83 is the molar mass. And the mass is 40.953. But one of the things that, of course, I've forgotten is that it's only 80% efficient. And so what we know is that we're not going to have the same mass formed in the end. So we take the mass, or you can take the mole as well, it doesn't really matter. And you can times it by the decimal 0.8 to get only 80%. So if you times it by 0.8, you end up with 32.763 grams. Okay, so that's the mass of sodium carbonate. And checking the significant figures, there are only 3 significant figures. So we just have to cut it off there. So therefore it's 32.8 grams. So that is the mass of sodium carbonate obtained.